So this is a in this session we will solve the question asked in the quiz. So the first question is, for an angle modulated signal xt is equal to 10 cos 10 to the power 8 pi t plus 5 sin 2 pi 10 to the power 3. Calculate the maximum frequency deviation. Calculate the max frequency deviation. So there are two ways to solve this problem. First, slightly longer version is, first we evaluate the instantaneous frequency, but it is obvious, I mean this is the way we should solve the problem, that the instantaneous frequency is 1 upon d theta it by dt. First we evaluate the instantaneous frequency, that is derivation or derivative of the instantaneous phase, and this is our instantaneous phase theta it. So if we just differentiate it, we will have this plus 5 into 2 pi 10 to power 3 into cosine of 2 pi 10 to power 3 divided by 2 pi. So this is obviously Fc. So what is the frequency deviation? The frequency deviation would be 5 into 10 to the power 3 cos of 2 pi 10 to the power 3. So maximum of this will be 5 kilohertz. So this is the max frequency deviation. The answer is 5 kilohertz. And students have also tried a different way, but I prefer this way because it's a very particular case, right? We can also change the multiple number of tones or different messages. In that case, the other method which we are going to discuss might not be feasible. So what students have done, that we know that modulation index is defined as maximum frequency deviation divided by the frequency of your message signal. So delta F max is beta Fm. Here beta is 5 and Fm is 10 to power 3. This is your Fm, right? Fm is 10 to power 3, 2 pi Fm. So of course the answer is 5 kilohertz. Next. The next question is, if a carrier is frequency modulated with the message signal of frequency 2 kilohertz, so message signal MT has frequency 2 kilohertz, it means Fm is 2 kilohertz, and the maximum frequency deviation is 5 kilohertz. Then what is the bandwidth? So if you remember, the bandwidth is 2 times beta plus 1 Fm, and beta is max frequency deviation divided by Fm plus 1 into Fm. So it would be 2 times Fm, 2 times max frequency deviation plus Fm. So 2 times 5 plus 2, it is 14 kilohertz. This was quite simple. And the next question is, there are two carriers. Carrier 1, the frequency of the center frequency of carrier 1 is 40 megahertz, the center frequency or the carrier frequency of the second carrier is 80 megahertz, and these two frequencies carrier are modulated by a signal frequency of 4 kilohertz. So this is the scenario 1 and this is the scenario 2, and we are claiming that the bandwidth for the scenario 1 is same as the bandwidth of scenario 2. So what is the ratio of peak deviations, peak frequency deviations, of course. So as we have seen that beta is plus Fm, which has nothing to do with the frequency, right? So if your bandwidth, excuse me, this is bandwidth, if the bandwidth is same, and so the max frequency deviation for both the scenario will be same. So the answer, the question was indicate the ratio of the peak deviation in the above two cases. I am just writing the whole question. Two carriers, 40 megahertz and 80 megahertz respectively are frequency modulated by a signal of frequency 4 kilohertz such that the bandwidth of the FM frequency modulated signal in both the cases are same. Both the cases are same. Both the cases are both the scenario are same. So indicate the ratio of the peak frequency deviations in the above two cases. So this is the question. So the answer is 1:1 because our bandwidth does not depend on the carrier frequency. So this was a trick question, and I think very few of you has solved it correctly. So the next question is, if your FM signal is given as cos into part 3t plus yt, so what is the bandwidth of this frequency modulated signal? So bandwidth is this, and your beta is 0.2, your FM is 10. So the answer is 24 hertz. It was also a very simple question. Now the next question is, if a sinusoidal message signal with frequency FM and amplitude 10 volt frequency modulates a sinusoidal signal, so the carrier frequency is 10 volt. So what would be the increase in bandwidth of your FM signal? In first scenario, in case 1, FM is 10 hertz. In case 2, your frequency is increased to 3 times. So the question is, what would be the increase in the bandwidth? So the bandwidth 1 for the first case is 2 times, max frequency deviation plus FM, and in second case the bandwidth is you have now tripled the frequency. So the difference, what would be the increase in the bandwidth?